Hello everyone, I'm Nadmuthaqib Khan, your host for today's video. Today I'd like to explain how to write the chemical formulas of ionic compounds, molecular compounds, as well as compounds that contain singular and polyatomic ions. So, without any further ado, let's begin. Before we analyze how an atomic bond is formed, we need to look at the octet rule. Elements 1 to 20 in the periodic table, except hydrogen, helium, and the noble gases, try to complete the number of electrons in their outermost shells to 8. In order to do this, they give, take, or share electrons. If the number of electrons in the outermost shell is less than 4, they are given. If it is equal to 4, they are shared, and if it is more than 4, more electrons from neighboring atoms are taken. Elements do this in order to achieve stability like that of noble gases, which are inert and don't react with other elements, because their outermost shell is already full with electrons. In all the types of bonds that we will analyze in this video, the elements that will be considered all obey the octet rule. Determine the electrovalency of the elements by checking the periodic table or the shell configuration. Alright, so we want to create an ionic compound using calcium and chlorine. So if we move on here to the periodic table group 2, we can see that calcium is a group 2 element, and we know that group 2 elements have 2 valence electrons in their last or outermost shells. That means when they combine with other elements, they give out those last 2 electrons. And if we move out here to group 17, we can see chlorine is one of them. That means, and we also know that group 17 elements have a valency or an electrovalency of -1, meaning when they combine, when they react with other elements, they take one electron from those elements. So as a result, calcium becomes positively charged. It gains a charge of +2, and chlorine gains a charge of -1. Determine the ratio of ions needed to achieve stability and neutrality in the compound. Now, to make it easier to understand how many of each ion we need, I've drawn some electron diagrams here. So I have drawn one calcium ion or atom, one calcium atom, and 2 chlorine atoms. Now this is because we really want to make an ionic compound with calcium and chlorine, but the thing is, calcium gives out 2 electrons, whereas chlorine can take only 1. But because we really want to make a compound with these 2 elements, calcium and chlorine, so we need another chlorine so that it can take that second electron that calcium gives. So in this case, calcium gives out its first electron to the first chlorine, and it gives out that second electron to the second chlorine. Therefore, we get the calcium chloride as the chemical formula. It's written as CaCl2. So this subscript right here, it represents the number of ions or atoms present in the compound. So we've seen that there are 2 chlorine ions and 1 calcium ion. Therefore, we get CaCl2. Write down the element with higher bonding capacity. Alright, so we want to create a molecular compound between carbon and oxygen, 2 nonmetals. Now, carbon has 4 electrons in its outermost shell, and oxygen has 6. So, because carbon has 4, it's going to share these valence electrons, and it's also going to be shared 4 valence electrons with, whereas oxygen is going to take 2 more electrons to complete its octet. So in this case, just like in the previous example with the ionic bonding, we need 2 oxygens because to effectively share all 4 of carbon's outermost electrons, we need two oxygens because oxygen can only take two electrons. So in this case, the sharing is going to be as follows. So here we have carbon. It's going to share two of its electrons with this oxygen and the other two electrons with this oxygen. So here we can see that carbon is sharing its two electrons here, electrons here, and it's also receiving two electrons from this oxygen and two from this one. So carbon has actually fulfilled its octet 1, 2, 3, 4, 5, 6, 7, 8 in the last shell, and oxygen has also completed its octet. So 1, 2, 3, 4, 5, 6, 7, 8, and this oxygen as well 1, 2, 3, 4, 5, 6, 7, and 8. So the difference between molecular bonding and ionic bonding is that the electrons are not being fully transferred. So they're not being fully given or taken. They are being shared mutually. So for this reason, we write CO2, the chemical formula. So just like in the ionic bonding example, the subscript here represents the number of atoms. So once again, we have two oxygens, one carbon, and we write carbon first because it has a higher bonding capacity. So it's actually sharing 4 electrons, whereas oxygen is taking 2 electrons. So because this has higher bonding capacity, we write this first. Right, I'm going to be showing you an easier way of writing the chemical formulas of ionic compounds and compounds which have elements and radicals. So for ionic compounds, we take calcium and chlorine once again, and we know their valencies. So Ca2 plus, that's calcium's valency, and then Cl minus, so 1, -1, that's the valency of the electrovalency of chlorine. So now basically what we do is we just write here CaCl, and basically what we do is we cross these over, we just swap them over, and the formula becomes CaCl2. Now the proof for this is that we can keep multiplying these as many times as required until they have the same absolute value, the absolute valency value. So already calcium has a valency of 2. Now we can multiply the chlorine another time, so times 2, in order to get a charge of -2. So now we have Ca2 plus Cl2 minus. So we can now cancel out these two charges to make this compound neutral. And therefore we can once again see that we have one calcium atom or calcium ion and two chlorine ions. Therefore the formula CaCl2. In the case of elements and radicals, compounds with these, it's very similar to ionic compounds. So we have to make sure that we multiply the element and the radical as many times as required until they come to the same number of charge. So we can see that we can multiply calcium by 3. So we can write calcium 3 times. And we can write phosphate 2 times. And then when we add them up, we get Ca 6 plus, and we get PO4 6 minus. So we get the same absolute value of charge, except that they are just opposite. So we can cancel them out, and we can come to the chemical formula Ca3PO4 2. Right? So that is because we have 3 calcium ions and 2 phosphate ions. Similarly, if we just use the cross method, we can just swap the charges once again. 2 plus PO4 3 minus. We can just do the same thing as before, cross method, and write Ca3 PO4 2. It's very similar to ionic compounds. Now being said, it is not suitable to use the cross method with molecular compound formulas. This is because molecular compounds have elements that may have varying valencies like transition metals. Therefore, when they react, they may have different charges at different scenarios. So molecular compounds are a bit more complex. So usually ionic compounds and compounds with elements and radicals can be written with the cross method. Thank you for watching this video. I hope I've been able to clearly explain the different types of atomic bonds. And if I did, please click subscribe and click that notification bell so you do not miss any future video updates. Until next time, stay safe and have a nice day.